A random forest example in Scikit-Learn. Here we are going to use the popular breast cancer dataset from Scikit-Learn library to make a prediction using random forest algorithm. The breast cancer dataset is a binary classification problem that contains 30 features and a total of 569 samples. This table shows the details of this dataset. To follow along, please open the IPython file, the template file related to this example, and start coding. Happy coding.
So as always, we're going to start by importing the libraries that we need. We're going to work with the breast cancer data, so I'm going to import it from the Scikit-Learn dataset library. Next, we're going to load the data and specify our feature variable and target variable. So I'm going to call my data cancer. And then the feature variable is going to be the data here, and the target variable is just going to be the target. Another way we could do this is we could use a function that is associated with the load breast cancer or any other data in Scikit-Learn, and that is asking for this parameter return x y. So x has to be capital. This has to be true. So if I get rid of this will still work. X is going to be my independent variable and y is going to be my target variable. So let's print out x and y here, the shape of them. So x is an independent variable. It has 30 columns or 30 features, and we have 569 samples of data. And y is the target variable, so it's just one value here. It's actually a classification. So next step is to go ahead and split our data into training and test before we can develop our model. So let's import the split function. I'm going to use random state 0, and I'm not going to use specify the test size, so by default it's going to be 25%. Right, so now we have the training and test data set. We can go ahead and develop a decision tree first, and after that we're going to grow a random forest. So let's import first the decision tree classifier. It's in the module tree, and the name of the algorithm is decision tree classifier. I'm going to call the algorithm my tree. I'm not going to specify any parameter here, and we can actually train our algorithm in the same line here. All right. Now that our algorithm is tuned, we can go ahead and make a prediction. Before that, we need to import the accuracy score to evaluate the performance of our algorithm. And then we're going to make a prediction on the test data set. And also on training data set. Let's print out the accuracy for these prediction that we made here. So we have about 87% accuracy score on test data and 100% on training data. So apparently our algorithm, our tree, suffers from overfitting. You might get a different prediction score for the test data. Let's try it again to show you that it might actually change. So right now I got 87%. If I run this part again and then make a prediction again, it can change. So right now I have 91%. The reason for that is there is actually a randomness here in when you define your or make a copy of the decision tree classifier. If you set up a random state here equal to 0 whatever, that's going to make sure that all of us would give the same output. So right now I got about 88%, and it doesn't matter if I run it again, it's going to be 88%. So nevertheless, we have overfitting problem here. So let's do some pruning to overcome this problem. So what we're going to do, we're going to use the parameters that we learned, such as the max depths, min samples, leaf, to restrict the complexity of the tree. So let's go ahead and create another tree. I'm going to call it tree number 2. So here in the parentheses, I'm going to specify these parameters. For example, max depths, I'm going to set it to be 4. We can play with this later on. On your own, you can actually change this data to see how we would change the behavior and accuracy of the algorithm. And I'm going to set the mean samples leaf to be equal to, for example, 8. And then we're going to set up the random state, of course, so that we would get the same output. All right, so next step is we want to make predictions. So before that, we need to fit our algorithm. We could actually do it here. And here we're going to make prediction. Make sure to specify that it's tree number 2. All right, and then we're going to print out the accuracy scores. So the gap actually has decreased considerably, as you see here, but it's still there is a little bit of gap here. So you can actually change these values to see how would that change the output of the algorithm. So as you see here, it changed a little bit. I'm going to make this, for example, bigger. Or smaller. Not much different. Well, change it. Right, nevertheless, we have a little bit of overfitting problem using the decision tree, even though we have done the pruning to simplify the algorithm, but still we have problem. Now we want to apply a random forest on our data. So first, let's import the random forest classifier. It's an ensemble module. I'm going to import it as forest to make it life easier. Now I'm going to make a copy of this as my forest, and this is going to be a forest copy. So before we do that, we can specify the number of features or k that we want to use here. So k equal to, for example, 8. And then here I'm going to say that max features equal to k, which is 8 now, and also random state equal to 0, so all of us would get the same result. Okay, we can also feed our algorithm at the same line. All right, so let's go ahead and make prediction. On the test data and on the training data. So let's print out the accuracies. First, it has to be the actual value, which is y test, and then the prediction. And then we're going to do the same for our training data set. All right. So the accuracy score on test data set is 99% almost, 90.986, and for the train data is 0.995, which is a much smaller gap than what we had for just a single tree. So you can go ahead actually and play with this value of k to see which one is better. So for example, I'm gonna go with 7 now. So this is not better. How about 10? So 8 seems to be the best. All right, generally you can here we have actually 30 features. So k, you can start with the square root of number of features that you have, and then try some k plus 1, for example, k plus 2, and also k minus 1, k minus 2, and then choose the best one, the random forest with the optimal k.